Okay. There were some issues with the videos being a bit blurry, so hopefully today's videos will be better. Last time we left off with integrals of more complicated trig functions, but I didn't get to talk about tangent and secant. So let's have an example with those. It's going to be useful for this lecture to remember that the integral of the tangent function is equal to the natural log of the secant, and I'm using x variables here, so it'll be secant of x, and as usual I have my constant of integration. Likewise, if I'm going to integrate the secant function, that's going to be, again, a natural log, but this time the natural log will be evaluating the absolute value of secant of x plus tangent of x. I'm not going to prove these today, but you can find a demonstration of this in section 6.2 of your textbook. Right. Let's try to integrate tangent cubed of x dx. Using my ideas from before, I want to use trig substitutions, or trig identities, to make this into an integral where u substitution will work. Right now, I could say derivative of tangent is secant squared, but there aren't any secant squareds in my integral, at least not the way it's written right now. So I'm going to use the formula that tangent squared evaluated at x is equal to the secant squared evaluated at x minus 1. So this was one of my formulas from Friday. It's really the cosine squared plus the secant, it's really the cosine squared plus the sine squared equals 1, but I've divided some things and rearranged. Let's see what the payoff is for this integral. I have the integral, let's call that a tangent squared evaluated at x times a tangent evaluated at x. And this isn't the usual way that we group functions together, but I'm trying to make the replacement here a little bit more obvious. My tangent squared, I say, is really secant squared of x minus 1. And here we have tangent of x dx. So I ask again, is this something I can use u substitution on? Well, part of it is. Just part. I could say that u is tangent of x, and here's my du, but it's got this minus 1 attached to it. So I need to multiply this out and see what I get. Let's call this integral of secant squared of x times tangent of x, and I'm going to subtract off tangent of x, and my whole integral is being evaluated against the variable x. So over here I could use a u substitution, and over here I have integral of the tangent function. So I'm going to split my integral and treat those parts separately. I'll call this integral of secant squared x, tangent of x dx, and I'm going to subtract off the integral of tangent of x dx. Now you can see why I needed this formula that I opened with. Here, again, I've been saying this several times now, my u will be equal to the tangent of x, my du will be secant squared of x dx. So this integral is really the integral of u du. And I need to subtract off this integral, the integral of tangent of x dx, which again is the natural log of secant of x. There's my constant of integration. So I know that this antiderivative of u du will be u squared. I'm going to go ahead and say, since u is equal to tangent, I'll get tangent squared here. And since my formula already has a plus c, I don't need another one.